Good morning, sixth grade. Hopefully, everybody had a great night. Today, we are moving on to chapter 11, lesson 2, triangles. Let's see how we got there. We are in our Google Classroom here. We're going to go into our classwork. Scroll down here to chapter 11. Click on chapter 11, and as you will find here, chapter 11, lesson 2 is right here on triangles. So click on that, and let's go over the information. So we have it right here. Chapter 11, lesson 2, triangles. Okay, so let's first talk about some triangles here. All triangles have one thing in common. All of the angles will add up to be 180 degrees of the interior, the angle. So if we take a look here, so it says the sum of the measures of the interior, that's important there, the interior, the angles will add up to be 180 degrees. So if we look here, we have angle Y, angle X, and angle Z. If we add these three angles up, they should come out to be 180 degrees. If they are more than 180 degrees, it is not a triangle. If it's less than 180 degrees, it's not a triangle. So let's look here at some of the characteristics of our triangles here. So if we take a look here, we have a triangle is made up of lines of our segments. We know there are three of them, okay? A line segment is a part of a line containing two of the endpoints. So if we see here, this is a line segment up here. Okay, it has two endpoints. Here's an endpoint here, and here's an endpoint here. A triangle is formed by three line of your segments here that intersect only at their endpoints. These endpoints where they intersect is called a vertex, okay? It's when this line segment here and this line segment here meet. They meet at this point here. This is known as our vertex. Now, we also have some other things in here. This area located inside the triangle, right in here, we call this an angle. So this is our angle right here. We have three different angles here in a triangle. And then as a triangle, we also know that they do have three sides. Here's one side, two sides, and three sides. So the three key points you need to know, actually four that you need to know here, is that a triangle is made up of the angles. It's made up of three, what we call our vertices, and three sides. And finally, they add up, all angles of the interior angles add up to be 180 degrees. Okay, so let's look at some examples here. So it says, find the value of X in the triangle PQR. So PQR. So we know, like what we set up here, the angle sum theorem of a triangle. We know that angle X plus 89 degrees plus 54 degrees must add up to be 180 degrees. So angle P plus angle R plus angle Q must add up to be 180 degrees. So X plus 89 plus 54 equals 180. So combine our like terms here, our constants here. Let's combine those. We add those together, we get 143. So X plus 143 equals 180. So then, in order to get this 143 to the other side, it's being added. Opposite of addition is subtraction. So then we'll subtract 143 on both sides. So that means the measurement of X is 37 degrees. Okay, so if you were to add up, once again, 37 degrees plus 89 degrees plus 54 degrees, that should equal 189 degrees. Let's look here at the next one here. We have triangle DEF, and they want us to find what the measurement of angle F is. Well, what's nice here, I am given two of the angles right here. I have angle E is 33 degrees, angle D is 100 degrees. So if we were to do angle E plus angle D plus angle F equals 180 degrees. So 33 degrees plus 100 degrees plus X must equal 180 degrees. So combine our like terms. Our 33 plus 100 is 133 plus the X equals 180. So this is positive. The 133 is positive. Opposite of positive is a negative. So we're going to subtract 133 on both sides. So subtract 133 on both sides. X equals 180 minus 133. So we get to X to be 47 degrees. So the measurement of angle F is 47 degrees. So 37 plus 100 plus 47 should total up 180 degrees. Okay, let's continue on to the next two here. Oh, we're going to deal with some ratios. Now, this is very important. Make sure you watch how we do this. The measure of the angles of a triangle ABC are in the ratio 1 to 3 to 8. What are the measures of the angles? What this means here, do not make this mistake. Don't just make sure. You do not say, oh, A is 1, B is 8. B is 3, C is 8. No, that means A is X or 1X. B is 3X. C is 8X. So we need to figure out how we're going to solve for X here. So we know that all of these angles here, the 1X, the 8X, and the 3X have to all add up to be 180 degrees. So I take X plus 8X plus 3X equals 180 degrees. So add these X's up. I have 1 plus 8 is 9. Plus 3 is 12. So I get 12x equals 180. And when we solve for x, x equals 15. Now, they want us to know the dimensions of all the angles. So I know that angle A, okay, is 15 degrees because we said x is 15. Angle B, okay, angle B is 3 times x. So 3 times 15 is 45. Okay, so the measurement of angle B is 45 degrees. And finally, angle C, 8 times 15 is 120 degrees. So if I add these all up, it should total 180 degrees, which it does. So let's look over here now. This one over here, it says, move myself down here. It says that the measure of the angles of a triangle XYZ are in the ratio of 2, 3, 5. Okay, what are the measurements of the angle? So we'll do x as the 2, so that's 2x. The y will do the 3, so that's 3x. And the z is the 5, so that's 5x. Okay, so once again, all we're going to do is add our 2x plus our 3x plus our 5x equals 180 degrees, because we know in a triangle, the total degrees is 180 degrees of the interior angles. So 2 plus 3 plus 5 is 10x equals 180 degrees. Divide both sides by 10, x equals 18. So we know x equals 18. So let's figure out what angle x is. Well, angle x is 2x. So 2 times 18 is 36. So the measurement of angle x, of angle x is 36 degrees. Let's go over here to the 3x, the angle y. So angle y we know is 3x. So we do 3 times 18, which is 54. So we know that the measurement of angle y is 54 degrees. And finally, let's go up here to z. Z up here is 5x. So I take the 18, plug it into my 5x. 5 times 18 is 90. So the measurement of angle Z is 90x. So there we go. We just solved all those problems because we know there's a total of 180 degrees in a triangle. Now let's look here at the exterior angles here. Okay. So if we scroll down here, it says each exterior angles of a triangle is formed by one side of a triangle and the extension of the adjacent side. So angles 4, 5, and 6 are exterior angles. So angles 4, 5, and 6 are exterior angles here. Now, just to show you here, angle 4 plus angle 1 equals 180 degrees. Why? Because they're supplementary. Angle 1 plus angle 4 equals a straight line, and we know that a straight line, which is known as a straight an angle, it does add up to be 180 degrees. So we also know that 2 and 6 equal 180 degrees because 2 plus 6 equal 180 because those are supplementary. Also 3 and 5. Angle 3 plus angle 5 equals 180 degrees also. Now, what they do not tell you here that you will learn your 8th grade year is angle 4 plus angle 5 plus angle 6 actually will add up to be 360 degrees. It actually does not matter on what type of polygon that you have. Your exterior angles will add up to be 365 degrees. So let's take a look down here. Let's see what we have down on here. It says, find the measure of angle 2 formed by the legs of the director's chair when the measure of angle 5 is 168 degrees. Okay, well, this is hard to read here. But let's take a look here. It sort of looks like what we have here. See if I can redraw some of this. We have a line that comes right up here, and we have a line that comes right here, and we have this line that goes across here. And this looks to be angle 1. This is our 4. This is our 5. And this here looks to be our 2 in here. So we'll work through this here. So it says angle 2 and angle 5, because here's angle 2 right here, and here's angle 5 right there. They are going to add up to be 180 degrees because they are supplementary. Now, we already know that angle 5 is 68 degrees. So if I go angle 2 plus 68 degrees has to equal 180 degrees. So with that being said, all I have to do is subtract 168 degrees on both ends of the equation. So 180 minus 168 degrees is 12 degrees. So the measurement of angle 2 is 12 degrees, which is right there, which is all they're asking for there. Let's take a look at this one here. It says in the figure below, measurement of angle 4, that's out here, is 135 degrees. They want us to figure out the measurement of angle 2. Now, there are a lot of ways to figure this out, okay? First of all, we know this angle here is 90 degrees, okay? We can use that. So 90 degrees here, okay? And I know that this angle 4 is 135 degrees here. So if this angle here is 135, it is supplementary, okay, to angle 1 here, okay? So if this is 135 degrees, this has to be 45 degrees. Okay, this is 45 degrees here. Now, all that I really need to do to figure out what the measurement of angle 2 is say, okay, what is angle 2 plus our 90 degrees plus the 45 degrees has to equal 180 degrees. Okay, so if I add these up here, okay, I'm going to get angle 2 is equal to, I'm sorry, back that up, plus 90 plus 100 plus 45 is 135 degrees, okay, equals our 180, okay. So we have that there. So in order to figure out angle 2, I'm going to subtract 135 on both sides. So we will figure out that angle 2 is 45 degrees. Now there's other ways to go about and figure this out here. We can do it all kinds of ways. So if we wanted to, when I said to you, remember external angles total 360 degrees. So what I did here in this example up top here, I took angle 5 plus angle 4, okay, plus this angle here, which if this is 90 degrees, then I extend this out, this is 90 degrees also. So I know that 90 plus 135 plus the angle 5 must equal 360 degrees. So when I do that, I figure out that angle 5 is 135 degrees right here. Okay, this is 135 degrees. So then to figure out what angle 2 is, since they are supplementary, all I have to do is do 180 minus your 145. I mean, minus your 40, minus your 180 minus 135. That equals 45 degrees. Very good. So let's take a look here and let's see what we have here going on next. Okay, so we're going to classify the types of triangles that we have. We can classify them two ways, by the angles and by their sides. Well, if we start here with the angles first, we're classifying them according to their angles. Well, there's three different ways we can classify them. One, we have a triangle that is an acute angle, which means all angles in the triangle must be acute. So we got 58, 52, and 70. We also have here an obtuse triangle, which means only one, because you can only have one obtuse angle in a triangle. One angle is obtuse. If you have one angle that's obtuse in a triangle, then it is considered an obtuse triangle. Now we're dealing with a right triangle, which means you must have one angle that is a right angle there. So that's how we classify them according to their angles. So now let's continue here. Let's look according to their sides. So by their sides, we have what's known as a scalene, an isosceles, and an equilateral. So if we look here with the scalene, no sides are congruent, which means all the sides have a different measure. This side is different than this side, which means it's different than this side here, which means all of the angles have, all of the sides have a different measurement. When we deal with an isosceles means, hey, we have two sides that are the same. And that's what these little tick marks here. That means this side is congruent to that side. So you must have at least two sides that are congruent. Equilateral, think about the word equal. That means all the sides are going to be the same size. And guess what? If all the sides are the same size, all these angles are the same size, and they're all going to be 60 degrees. Very good. Okay, they're each angle here in an equilateral triangle. Each angle is 60 degrees. So let's look at some examples here, and then we'll move on to our last examples here. Okay, here, all they want you to do is to classify each triangle by its angles and its sides. So if we take a look here, let's look here. We can look here and say, oh, guess what? We have a right angle here, which automatically means this is a right triangle. Now, let's look at the angles here. As you see, all these angles are different. This is 90 degrees here. This is 50, that's 40. Since all the angles are different, that means all the sides are different measures also. So that means each one of these sides is different. Since all of these sides are different, that gives us a scalene triangle. Let's look here. In this next one, we have an obtuse angle here. So since we have an obtuse angle, we have an obtuse triangle also. But let's take a look here at the angles. I have 106, I have 38, and I have 36. All of these are different. So that means all of these side lengths are different also. Let's look at the next one here. Last two. So if we look here, guess what we got here? We got a right triangle because we have a right angle here. So it is a right triangle here. But let's look at the sides. I have a 45 degree angle and a 45 degree angle, which means this side is equal to that side. Since we have two sides that are equal, this is known as an isosceles triangle. Finally, the last example that we have, if you see here, we have 44, 68, and 68. These are all acute angles, which means this triangle is acute. Since this triangle is acute, then we call it an acute triangle. Now let's look at the sides. If we look at the sides, I got a 68, and I got a 68, and I got a 44. But I have two angles that are the same, which means this side's going to be congruent to this side, which makes this officially an isosceles triangle. So hopefully, guys, you understood what was going on. And if you did not, watch the video again and then get started on your homework. Other than that, guys, have a great day. Talk to you later. Bye-bye.